My name is Veronica Macias from Eisenhower High School, and my science fair project is accuracy of optical brightening detection in different water types. Optical brighteners' ability to brighten and whiten cotton clothes makes it commonly found in laundry detergents found in the United States. Although optical brighteners are not harmful to people, they can be used to detect untreated or inadequately treated water. If optical brighteners are found in water, that water may potentially contain pathogens or other dangerous substances. This is useful when determining if certain water storage is at risk of contamination if not properly cleaned. Although there are many methods to detect unsanitary water, optical brightening monitoring is easy for anyone to obtain and use compared to store-bought kits. After detection of water not fit for consumption, this unsafe water can be treated in a multitude of ways. One of the most common ways to make water safe is to boil it because the process kills microorganisms that may cause disease. Water can also be sterilized when mixed with chlorine as it also kills pathogens inhabiting the water. Another method of purification is passing the water through filters usually made of sand, gravel, cotton, and charcoal. By using the optical monitoring technique, I can also observe the effectiveness of these water purification methods and detect if any optical brighteners are seen. This experiment is meaningful to me because a lot of people don't have a reliable source of clean water and have to risk drinking water contaminated with fecal matter or harmful bacteria. By testing the accuracy of optical brightening monitoring by comparing it to a store-bought test, I can ascertain an alternative method of water testing that is affordable and easy to apply. The rationale of this experiment also tests different bodies of water frequently visited by people to test if any of these areas are at risk of fecal contamination. Bodies of water people frequently come into contact include tap water, pools, bayous, oceans, springs, and wastewater. By testing different types of water to detect optical brighteners, I can observe if people are at risk for coming into contact with unsafe water. The recent questions for this experiment include: do different types of water have different levels of contamination? How does optical brightening monitoring compare to store-bought coliform detection tests, and is it more efficient? Can optical brighteners be observed in various water purification methods? My first hypothesis is that the store-bought coliform tests are more accurate than the optical brightening monitoring technique. This will be due to the store-bought tests changing colors to show results, while the OBM is observed under UV light, making it less visible and more likely for the observer to make errors when connecting data. 2. The OBM will be able to detect contaminants other than coliform because the presence of optical brighteners suggests improper purification of water, which includes debris and non-living trash. Independent variables include the number of coliform, non-living waste, water sample locations, and optical brightener present in water samples. The dependent variables include the color of the water kit and the color of clouding under the blacklight flashlight. 3. Controlled variables include the time spent absorbing water samples and the location of the OBM conducted. The materials include the untreated cotton tampons, the empty water bottles, the multi-use rope, backlight for fluorescent flashlights, water samples from various locations, a water testing kit, gloves, aluminum foil, chlorine, and water filter. The procedure for the OBM technique begins by first taking an empty water bottle and cutting sections 6 to 8 inches long. Next, make 4 small holes in each section and slide the rope through them. After that, open the water bottle and insert cotton tampon inside, securing it in place by screwing the cap with a tampon string in between. Make sure to wear gloves when handling tampon. 4. Suspend the bottle using the rope and leave the bottle in contact with water sample of 24 to 48 hours. 5. Collect bottle and carefully remove tampon, making sure no contact with bare hands and debris, and wrap with aluminum foil. 6. Move to a dark area to examine tampon for presence of optical brighteners using a blacklight flashlight to view it. The presence of optical brighteners indicate waste and untreated water. This is an example of an OBM kit, but with some variables changed, such as the PVC pipe and the fabric pad. The procedure for the water testing kit begins with opening the water kit and fully filling the containers provided. Then wait 72 hours for the containers to change color. If the bottle is yellow, no coliform is detected, and if the bottle is purple, the test is positive. This is what the water testing kit should look like. These are the results for the OBM techniques for tap water, storage water, and spring water. For all 3 tests, optical brighteners were detected, but only the storage water had a presence of coliform. For the OBM results for pool water, ocean water, and coliform water, only the pool water and ocean water had a presence of optical brighteners, but the coliform water was positive in E. coli or coliform. These are the OBM results on different purification methods like boil water, chlorine, and filtration. The boiled water had no presence of optical brighteners, but chlorine and filtered water did. All three of the tests also had a negative test of coliform. Even though the filtered water and chlorine water have optical brighteners, they have less than the previous examples, meaning that these are effective methods, but the most effective is boiled water. This is the number of optical brighteners found in the water samples. In conclusion, I can conclude that the OBM technique accurately detects contaminants in water. I'm surprised that the results of the tap water and spring water test showed optical brighteners, as the water testing kits for water samples didn't detect coliform. Even though the optical brightening monitoring and coliform detections are used to detect fecal matter contamination, the experiment shows that there may be different levels of contamination. We may have water that is inadequately treated but without the presence of bacteria. For future projects, I recommend to find a better way to record the optical brighteners while using the OBM technique. Not include data relevant to the experiment, collect more water samples to compare different types of water people frequent, and prevent unnecessary contact of optical brighteners with the tampons used. These are the preferences for the experiment.